Thank you. Welcome our viewers today. For continuation of what we had the day before yesterday on Monday. Today we said again we shall embark on our revision again. We will be doing it over the time, especially during this period that we can no longer go to school. We need to help one another, and I will encourage ourselves or the society, now that we economically we are limited, socially we are limited. Let us develop an habit, an urge to help one another, in where we need one another, because this is an ecosystem. We need one another, and no one is an island. We need to help one another, and at the end of the day, God will receive all the glory because He is our God. So today, I would like us to back on the vision on equation of straight line. As you can see from our board, we have equation of straight line. And there are some few things I would like us to note before we are back on the revision of straight line. There are some few important things that we shall encounter as we revise the topic equation of straight line. And one of them is axis, y-axis, and the x-axis. One of them is the x-axis and the y-axis. X-axis is where the line intersect the intersect the x-axis. Then we have the y-intercept, where the line intersects the y-axis. And something else to note, where the line crosses or intersects the y-axis, the value of x is 0, because this is 0. Then where the line intersects the x-axis, the value of y is equals to 0. So then again, important to note, there are some things which usually we normally confuse ourselves in. It is that the lines that are vertical or parallel to y-axis, they are x's. For example, we can have x is 1, x is 2, x is 3, x is 4, 5, 6, 7. These are the lines we call x's, the vertical lines which are parallel to y-axis. And when we name the other vertical line, that is y is equals to 1, 2, 3, 4, 5, 6. These are the lines we call the y's. For example, this is line y equals to 1, y equals to 2, y equals to 3, y equals to 4. And on the other one, this one is x is equals to 1, and so on. So the x's are vertical lines parallel to y-axis, but y's are lines, horizontal lines that are parallel to x-axis. Then something else to note on equation of straight line, it is the gradient. Gradient is the steepness or how slope the line is. For example, if I draw this line, this is a slope line. This is a line that is slope, it is steep. So if I draw another line, this one is also a steep line, but this one is more steeper than this one. Therefore, this one has a higher gradient than this one. This one has a higher gradient than this one. It is more steeper than this one. The rate of change of x-axis as a result of change in y-axis, that is the steepness, that is what we call gradient. What do we mean by that change? For example, if we move from this point, we have point Q here to point R. If you move from point Q to point R, or you can assume a randa, whereby you use a randa to climb up on a wall. When you use that randa to climb over, you are covering some distance on the horizontal and some distance on the vertical. So that distance you are covering simultaneously. You are covering the horizontal and the vertical distance horizontally using a randa, which we can call a hypotenuse. In our case, where this is the vertical, this is the wall, this is the floor. When you're using this randa to climb here, every distance you cover, you are covering some distance horizontally and some distance vertically. This rate of change cover the distance you are covering. If you move, for example, from this point to this point, this distance you are covering here horizontally. As a result of this change you are covering here vertically, the rate of change of this distance as a result of this distance, because as you move on, this distance increases. As you move on, ukifika when you are around at this point, this distance is more bigger. So this is larger, the distance is longer. So as you reach this point, also the horizontal distance was changing, because you are at this point now. When you are at this point, the horizontal distance has changed and the vertical distance has changed. So the result of change of the vertical distance as a result of change in this x distance or the horizontal distance is what we call gradient. For example, if you look at this Q, as you move from point Q to point R, here we have this, maybe the value of x was 5, and at point R the value of x is 3. So the displacement is 2. And what is the displacement on the y-axis? From point Q, where y is 2, and the point R where y is 4, the displacement is 2 again. But when you look at another line here, the second line, which has a different gradient, when we move from the same point here, where we have 5, we have x as 5, then we move to this point here, where x is 1, the displacement of x-axis is 4. 5 minus 1, which is 4. But on the y-axis, it is 4. So change on x-axis as a result of changing y-axis is different here, is different in this line from this line. So the two lines have different displacement on x-axis, on y-axis, sorry, as a result of change in x-axis, because they have different gradient. They have different steepness. There is a line that is more steeper and another line is less steeper. Now we can come to our equation here that we are supposed to solve that is the linear equation that we are supposed to solve out. And something else to remind ourselves also is the form in which you have been used to write a linear equation. That is form of y equals to mx plus c, whereby m has been used most to represent gradient and c to represent intercept. Y-intercept, c to represent y-intercept. If you want to get value of x-intercept, in this case, you substitute and you replace the value of y with 0, because we say at where the line crosses the x-axis or intersect the x-axis, the value of y is 0. So you get the value of x at that, you get the coordinate of the x-intercept. Then again, something else to note is about the relationship between gradient when the lines are parallel, when the lines are perpendicular to one another. And to remind ourselves, we've said before, when the lines are parallel to one another, the gradient are the same. If the gradient of this line and the gradient of this line, if they are parallel, it means they will never meet. The gradient is the same. The steepness is the same. The steepness is the same. So the gradient is the same. Therefore, the equation, the value of m will be the same, will be equal. Then again, it is the relationship between a line and a perpendicular line. If a line is perpendicular to another line, where they are meeting at an angle of 90 degrees, the gradient, the product of the gradient of line 1, which is m1, multiplied by the gradient of line 2, which is m2, will result to negative 1. Having noted some few points that are necessary in our revision, we can embark on our revision and do some of the few questions and remind ourselves. It is something we've done in Form 2, so we are just reminding ourselves. If the equation, remember repetition creates retention, therefore we need to repeat, revise again until it is in us. So if the equation of line RV is equal to 3.2 plus a quarter V, where R and V are variable, remember we said y equals to mx plus c, we said x is a variable, y is a variable. These are a constant, these are constant. X is independent variable, y is independent variable. Y depends on x, but x is independent, it depends on itself. For example, I give an analogy of whereby we have weather. Our behavior of wearing clothes, wearing heavy clothes, wearing light clothes, depends on the weather. But for instance, when it is rainy, we shall find ourselves wearing heavy clothes. But when it is sunny, we find ourselves wearing light clothes. Some of us will wear vests and move out because it is hot. When you go to Mombasa, you find that the people stay in the beach with almost naked because it is sunny. It is very hot. It is very hot. But the weather being hot, for example, if it is rainy, weather itself does not, weather influences how we wear clothes, but our behavior of wearing clothes does not influence weather. We cannot wear heavy clothes, then it becomes rainy. Or we wear light clothes, then it is hot. No, but weather influences our behavior. So we are dependent on weather. Our behavior of wearing clothes is dependent on weather, but the weather is independent. It controls itself, but our behavior of wearing clothes is controlled by weather. So this way, Y is independent on X. X is independent, it depends on itself. So they are variables. And we say in linear equation, not necessarily X and Y. We can use any other variable. We can use A and B. We can use B and K. Any variable that is unknown, we can use it to in linear equation, not necessarily X and Y. Some of us have been asking equation, we've been finding value of X since class 6. We've never found the value of X. It is disturbing, but that is the joy of mathematics. That is the joy of mathematics. You find the value of X in one equation, you find the value of X in another equation, and the values are different. They are not equal, and it is the same X. They are unknowns. They assume any value. Now, in our case here, we have RV, which is equals to 3.2 plus a quarter V, where R and V are variables. Determine the gradient and the y-intercept. Our equation is RV equals to 3.2 plus a quarter V. Our basic, our first step is trying to write the equation in the form of y equals to mx plus c. But in our case here, because we don't have x and y's, we can determine, or we can establish to write the equation in the form of r equals to mv plus c, where v is it takes the place of x, r takes the value the place of y. M is the gradient, c is the y-intercept. They are constant, they remain that way. So how do we make this equation how do we write this equation in the form of r equals to mv plus c? In our case here, on our left hand side, we have r and v. Remember, we want to be left with r alone. So what do we do to our left hand side? We divide by v. So in our case, we shall have r v equals to 3.2 plus a quarter v. Here we divide by v. We divide by v. We divide all through by v. Whatever you do to the left hand side, you do it to the left hand side. To the right hand side, sorry. So in our case here, we are left with r equals to 3.2 over v plus a quarter. Our equation is already in the form of r, m, v plus c. And what did we say about m and c? We said m is the gradient, which is 3.2 in our case, and a quarter is the intercept, the y-intercept. In this case, it will be r-intercept, because we assume the graph was in the form of rv. This one being the v, this one is the r. So in our case, it is 3.2 is the gradient. Then the y-intercept or r-intercept in our case is equals to a quarter. Is equals to a quarter. That is simpler. We can tackle another one. And that's how mathematics is easy. It is easy. It is more easier than remembering the first white man to see Vasco da Gama. Is this Vasco da Gama or those things? Yeah, it is easier than remembering those things. You can see I can't even remember. So in another example is a straight line. A straight line, that is one passes through point -3, 5, and we are told this line is perpendicular to another line, which is line 2, whose equation is 2y minus x plus 4 equals to 0. Find the equation of line 1. If the equation is find the equation of line 1. These are two lines. We are given two lines and we are told that the lines are perpendicular. So the first thing we do is to write the equation that we already given in the form of y equals to mx plus c. In our case, the equation is 2y minus x plus 4 equals to 0. We want to be left with y on one side, that is the left hand side, so we have 2y equals to, we take x on the other side, it is negative, and note this one very carefully, it will be positive, so it is x minus, this was positive, so it will be minus 4. Then from there, we divide all through by 2 to be left with y on one side. Divide by 2, we divide by 2, we divide by 2. And then we will be left with y equals to half x minus 2. That equation is already in the form of y equals to mx plus c. Therefore, the gradient is half. The y-intercept is negative 2. Remember, we want to find the equation of one line that passes through negative 3, 5. These are coordinate, where the value of x is negative 3, the value of y is 5. This line, that is line 1, passes through this point. But for us to get equation of a line, we must have gradient and 1 point. We must have gradient and 1 point. In our case, we don't have gradient, but we have gradient of line 2. This is line 2. But remember, we saying there is a relationship between the gradient of two lines that are perpendicular to one another. So therefore, what if line 2 is perpendicular to line 1, what is the relationship between their gradient? Remember, we said gradient 1 multiplied by gradient 2 will give us negative 1. Therefore, negative 1 is equals to m1 multiplied by m2. That is the gradient of the line 2, which is in our case half. Therefore, negative 1 equals to half gradient 1. We multiply them by 2. We multiply them by 2. And we get our m1 is negative 2. The gradient of our second line will be negative 2. Note this one and keep it because it is our darling. We shall use it to find the equation of straight, the equation of the first line. That is the first line. Now, having got the gradient of the first line, and we have 1 point of that line. And we have 1 point of that line. We find the equation of that line. So, finding the equation, we assume any value, x and y, any value that we don't know, any coordinate of that line, and another coordinate that we already given, that is negative 3, 5, and the gradient, which is negative 2. We find the equation of that line. So, remember we said the gradient of a line is equals to y change over x change. What is the change in y as a result of x change that is given by change in y over change in x. In our case here, we have a change in y. We can say y minus 5, that is change in y, divided by change in x, that is x, minus, remember this one was negative 3. So it is minus 3 is equals to negative 2. This one will be equal to y minus 5 over x, negative multiplied by negative is equals to positive 3, and all this one is equals to negative 2. We can simplify this further by multiplying these signs by x plus 3 and the other sign by x plus 3. We shall be left with y minus 5 is equals to negative 2x minus, remember we said again yesterday, whenever you see a bracket, take care of the negative. So this is negative 2 multiplied by positive 3, which will give us negative 6. And in our case, we shall have y equals to negative 2x minus 6. We take 5 on the other side, it was already negative, so it is plus 5. And this one will give us y equals to negative 2x minus 1. The intercept, the y-intercept of the first line is negative 1. The gradient is negative 2. This line and this first line that we already given here, there are two lines that are perpendicular to one another. The gradient, the product of the gradient is equal to negative 1. Negative 2, if we multiply by a half, which is the gradient of the second line, it will give us negative 1. That one is a bit simpler. You can have another one. We can have another one, a more simpler one. 5. Yes, we are find the equation. Find the equation of a line passing through point negative 3 again and 5, and it's perpendicular. It's perpendicular to the line 2y plus x minus 3 is equals to 0. You can copy that one. It is similar to the one that you've already done. You can do it. You can try to do it for your practice. Find the equation of a line passing through point negative 3, 5 and perpendicular to the line 2y plus x minus 3. It is more simpler. You can try to do that one at home. Although we are already at home, we are working at home, we are doing everything at home, and it shall be well. You can copy before we rub. You can copy the question, then do it at home. Try to solve it just the way we solved the other one. In case of any problem, in case of any question, you can raise it on our online on our Facebook. Very soon we shall be on YouTube. You can just raise your concern. We shall be able to go over it again in our next lesson. Then as you copy that one, we can do another example that is a little bit different. A straight line through the point A, which is 2, 1, and B, which is 4, M is perpendicular to the line, whose equation is whose equation is 3y equals to 5 minus 2x. Which is 3y minus is equals to 5 minus 2x. Then we are going to determine the value of m and the equation of line A, B. That's a little bit different, but it's almost the same, like the one we've already done. A straight line passes through point A, which is 2, 1, and a B that is 4m is perpendicular to the line whose equation is, so it is perpendicular to, in mathematics we've moved from known to unknown. In our case we have a known, that is 3y equals to 5 minus 2x. Remember, we say in linear equation, we try to first write the equation in form of y equals to mx plus c. In our case, we want to be left with, we can rearrange this one to have 3y equals to negative 2x plus 5. It is the same. Then we divide over all the room by 3, such that we shall be left with y equals to negative 2 over 3x plus 5 over 3. That is our equation. Our m is negative 2 over 3, which is our gradient. And we are saying that line is perpendicular to another line that is moving through point A and point B. So the gradient of line, the other line, that is moving from point A to point B, if we multiply this gradient of this line, that is line AB, as gradient m1. This second line that we have, it has m2. If you multiply these two gradient, they should give us negative 1. Therefore, negative 1 is equals to gradient of the second line, that is negative 2 over 3, multiplied by gradient of the first line AB, which we are told the line passes through point A and a B. Now, in our case, we multiply this line by 3 over 2 negative, and this one by negative 3 over 2. This one will give us m1 is equals to positive 3 over 2. That's the gradient of line AB. Now, in line AB, we've already been given 2 points. That is point A and B. One point B, point A is 2, 1. Point B is 4m. The first equation we are required to find the value of m. That is the value of m. And how do we find the value of m? Remember, we are given the gradient of the first line that we have. It is 3 over 2. So we have a change in y, which is m minus 1 over 4 minus 2, which is the value of x. This one should give us 3 over 2. We cross multiply. This one will give us 2m minus 1 is equals to 3, 4 minus 2. This one will give us 2m minus 2 is equals to 3 is equals to 6. 3 multiplied by 2, it is 6. Or 3 multiplied by 4 minus 3 multiplied by 2, which will give us 6. So what is the value of m? 2m is equals to 6 plus 2. 2m is equals to 8. And the m is equals to 4. So the value of m here, so point B, sorry, hope you've already copied this one. So point B, A is 2, 1. Point B is 4, 4. Point B is 4, 4. So we find the equation of line AB. Finding the equation of this line AB, we can assume another value, which is a general value, which is x, y. Then we use either of the coordinate, either B or A, whichever coordinate we want to use there. And maybe in our case, we can use B, coordinate B, which is 4, 4. And again, this is a general value. What is the change in y? Change in y over change in x is equals to the gradient. Change in y over change in x. This one will give us 4 minus y. Whichever way you want to put it, it will give you the same result. 4 minus x is equals to our gradient, which we found it is equals to 3 over 2. Yeah, if we cross multiply, we get 2. 4 minus y is equals to 3, 4 minus x. This one will give us 8 minus 2y is equals to 12 minus 3x. We can write it in form of, this already our solution, but we can write it in form of y equals to mx plus c. So we have negative 2y is equals to 12 minus 3x. We take 8 the other side, it becomes minus 8. This one will give us, it will give us negative 2y equals to negative 3x plus 4. That is 12 minus 8. It will give us 4. Then we divide here by negative 2. By negative 2. We divide by negative 2. This one will give us y is equals to 3 over 2x plus, sorry, it is positive 4 divided by negative 2, which should give us negative 2. And this is our solution. That's our solution. That's a little bit challenging, but you can go over it again, find the value of m, find the value of equation. Again, if you find a problem, we can always help one another. But mathematics, it's just a game. You play with the numbers, you find the solution. And remember, we said in mathematics, we don't get answers. And that is why working is very important in mathematics. Just have a good flow of working, you get marks. You can miss all the answers in a question. In a paper, you can get 0 answers, 0 solutions, but you get 70 out of 100 because you've already worked very well. You've shown you are working, and if you play that game very well, it is very easy. It is an easy game, and you enjoy the game. You enjoy